Welcome to part 2. Sorry, we're cut off somehow. So there were two problems in the homeworks, and this is number 32. And it is initial value problem. So I want you to actually find the general solution. Okay. Now, I raised something. I forgot. Oh, sorry. I forgot to write something. Namely, they gave us what a fundamental system. What was that for weird thing that happened here? X minus 1 EX and X minus 1. This was a general solution, fundamental system of solutions for the homogeneous solution. So we don't have to work that. We wouldn't have really good techniques yet because this is not a constant coefficients, right? All right, so let's step 1. So, well, before I do that, perhaps let me say, what does it mean? Well, because we're going to use it and need it later anyway. That means that the general homogeneous solution is A times, I'm going to take x minus 1 first. Seems to be easier, right? B times plus B x minus 1 EX. So in A, B are general coefficients here, constants. Okay, that's how the general homogeneous solution looks like. Now, step 1 is the variation of parameters suggests a certain solution that involves two parameters, u and v, where we basically replace these constants by these parameters. That's perhaps the easiest way to say it. So u and v are going to be parameters, which means in our context here that they depend on x. Now, you could now plug this in and start calculating, but we can skip a step, and what we say is, so let me box this because we're going to have to go back to it, right? So this is where we're going to get, but so this leads to we create a system of equations. What you really do is this: the first one is actually really the equation that an additional equation that you put there. It's kind of weird. Why can you do that? Well, because you have two UVs, you have that much freedom. You can even impose an extra thing. I could say, Professor, if that's the case, then I would like to put u equal to 0, right? If I can make an extra thing, why can I not do that? Sure, but then what you're doing, basically doing that, if you put u equal to 0, what are you doing then? Then you're doing the method of reduction of order. And reduction of order works, right? Because you can use either one, right? So this is exactly what you're not doing. You're saying, okay, that's one option I have, put one of these 0, but the option I'm going to go for is that u prime and v prime satisfy an additional equation, namely, so in other words, I replace u and v by their derivatives. That's not the same thing as taking the derivative of this thing, right? If I take the derivative of this thing, then I would also have to take the derivative of these other factors, but I'm not doing that. And the other one is, and now you have to be careful. So here's f of x is equal to, what we now do is we take the derivatives of these guys. We copy these guys, but we take the derivative of these things. The derivative of x minus 1, that is 1, plus v prime, and the derivative of this thing, well, that's a product. So derivative of x minus 1 is 1, plus, and now I copy the first, take the derivative of the second. Now this is actually nice, right? This is ex plus xex minus ex, so actually you see that this cancel. Now what is f of x? Okay, and here you have to be really, really careful. I admit I made a mistake myself, and I got a very awful integral that I had to solve. Because you say, okay, fx is this. Yes, that's if in your standard form, but this is not in standard form. This is x minus 1 squared in front of that. So be very careful if these things are not in standard form. What we have to do, therefore, is to write it in standard form. So I'll do this up here, perhaps, is divide everything by x minus 1 squared. So this would be y double prime minus x squared minus 1 over x minus 1 squared. That's not the same thing. They don't cancel. There's a part that cancels, but let's not bother about that. X plus 1 over x minus 1 squared equals x minus 1, because the origin was power 3, but we cancel 2 of them, ex. So this is my f of x. Okay, so be very careful. So this is x minus 1 ex. So let's write down what we have one more time. U is u prime x minus 1 plus v prime x minus 1. Oh, okay, sorry, yeah, sorry. Let's do this before I write it. We see that we have a common x minus 1 that, of course, in 0, we can cancel it out. We are allowed to do that, right? Because the only thing what we then not allowed to do is look at the point x equals 1. There will be no solution in that point. So if I do this, then the equation becomes even much simpler, right? Then the first equation becomes 0 is u prime plus v prime ex. And what's the second equation now become? Well, that is now x minus 1 ex, right? That is the fx here. And then this is u prime plus v prime x ex. Okay. And then this is a system that we solve. We think of u prime and v prime as unknowns, and we solve for them. And we can do either substitution or we can do elimination. Whichever you want. I'm going to do elimination here. I'm going to multiply this with -1 and add it to that. Because then, okay, here nothing happens because there was a 0 on top. Then this becomes now minus u prime, and added to u prime, they cancel each other out. So we get here the minus sign here, so we get v prime x ex minus v prime ex. Also, I can factor out the v prime and ex, and I'm left with an x minus 1. Oh, that is so nice. So much cancels again. These two, everything cancels. And, well, but I have v prime equal to 0? No, v prime equal to 1, right? V prime is equal to 1. Professor, can I integrate? Yes, you can, because that is just x, right? Plus a constant. Do we take care of the constant? No, we're looking for a particular solution. In the variation parameters, we're looking for one because we have the full homogeneous one. So we don't, there's the difference, right? When we do reduction of order, we only have one homogeneous solution. We don't know the second one yet. So we must find the general solution through our method. Once we have both, then we can do the trick. That is that a general solution is a linear combination of the fundamental system of homogeneous plus a particular. We have the fundamental system, so we only need a particular. Okay, so V is x. Sometimes perhaps, because everything is on powers of x minus 1, it might be better to take this one. Okay, I'm just putting it there. We'll see whether we need that or not. Let's, what do we do now? Well, we plug this in one of the equations, solve for the other one, right? So we solve for v prime, now we have to solve for u prime. So if I plug this into the top one, 0 is u prime plus ex. That's again very simple, right? That's minus ex, so we see that u is again minus ex. Are we done? No, because remember, u and v were part of these parameters that defined y. So that was minus ex, x minus 1. And that's this one, plus v. V was what? V was x, sorry. V was x, so I shouldn't write v, right? I should write x. So it's x times x minus 1. Yeah, so v is x and then x minus 1 ex. See? In fact, this is even, you can even combine this, right? We can factor out an x minus 1 ex, and what I'm left with is x minus 1. So this whole thing is x minus 1 squared ex. If you didn't see that, you don't see that. That's not a big deal. It will follow anyway once we're going to do our general solution. So step 3, I guess this was step 2 when you put everything together. This is a particular solution, so let me indicate that now. So the general solution is the particular plus the homogeneous. I'll write down one more time the formula. So in this case, this means x minus 1 squared ex plus a times x minus 1 plus b times x minus 1 ex, right? That's the homogeneous. We had done it right. So yeah, here they are. Now there was an initial condition, so that's step 4. And the initial condition was that at 0, y was 4 and the derivative was 6, minus 6. Sorry. If x is 0, then y is 4 and y prime is negative 6. Did I say it now right? Or 4 and minus 6, okay. Okay, so these two we can plug in and we get in this general, 4 is equal to, the x minus 1s will be minus 1s, okay? if I plug in 0, so minus 1 square, of course, is completely is 1, and then e to the power, that is also 1, so that gives me a 1 here. Then plus, that is a minus a, and here I get a minus b, right? Because this will be minus 1, this will be 1, okay? So this tells me that a plus b is equal to negative 3, bring the negative y's to this side and that side. But what I need is y prime. Okay, I need y prime. It's a little bit of work. The derivative of the first factor, copy the second, plus copy the first factor. I hope everybody knows the product rule. We have been doing it so many times, you would be really lost if you don't understand the product rule, right? The derivative of a, that is a, and the derivative of that one, again, is the product rule. Ex plus bx minus 1 ex. And so if I plug in now these two, then I get that minus 6 is equal to minus 2, right? This will be 1. Then plus a, there's nothing there. That is a plus b, and that is a minus b. Oh, so the b's cancel, and I see that a is minus 6 plus 2 minus 1. That seems to be minus 4. No, that's not right. Minus 5. Okay. I guess so. Right. Yeah, minus a minus b. I have the feeling that I do an extra. Oh, no, I have to take the derivative. Okay. So a is negative 5, and therefore negative 5 plus b is negative 3. That means b is 2. Okay, so the general solution is y is equal to x minus 1 squared ex. What was b? A was negative 5 x minus 1 plus b was 2 plus 2 times x minus 1 ex. You see that we can factor out an x minus 1 if you want to. And what we have left is an x minus 1 ex minus 5 plus 2. Oh, that's an ex here. 2ex. Let me double check. But I could have made a calculation error in the somewhere, but I think it's, if it's not correct, it's very close to correct, and that's already a lot of points. If you make little things, mistakes like that, I really don't care much about that. Oh yeah, they have grouped it together in a different way. You're right, I should take these two guys together. I don't know why I didn't do that. That is x minus 1, and then we have an x plus 1 e to the x minus 5. So, right, that's the same thing. In the textbook, they expanded this again, and it becomes an x minus 1, then x plus 1 is x squared minus 1, and minus 5 x minus 1. So you see this, each of these forms are correct, and they're just different ways of simplifying. And these things are not even clear anymore what is the most simple form of writing it. So I'm definitely not going to insist that. Okay? But when you're dealing with these things and you solved it, and then you compare it with the solution at the back, and it looks the same, but it is not entirely the same. It might be. So sometimes you need to manipulate a little bit, and as I said, sometimes they take weird choices. Why to write it this way? To me, it seems that this would be the most factored form. Why not leave it that way? But never know. And if it looks wildly different, yeah, then probably it's not the same. Okay, and you probably made a mistake. And I said a very common mistake here is to not take this to be the f, the forcing function, and the forcing function you can only see when you write it in standard form. Okay, this is not standard form because in x minus 1 squared you have to write it this far, and then you see what the forcing function is. All right.